Alright, this video is going to be kind of putting it all together, so finding all the things that you can find from the original form of the function, from the factored form of the function, and then continuing on to sketch the graph so that we can find the things that we need to find from the graph. So first I'm going to go ahead and look through the things that I know from the original function. So one of those is the y-intercept. So I need a number on the end to work with here. So 3 divided by 0 is not possible, I can't do that, and so for the y-intercept I'm going to say that there is none. The next thing I can tell is whether or not there's a horizontal asymptote or an oblique asymptote, so I'm going to look at these for that. The numerator of the top is bigger, the degree of the numerator is bigger than the degree of the denominator, and so that means that the horizontal asymptote is y equals 0, and that there is no oblique asymptote, because you can't have both, it's just one or the other. And then at this point I think I've found everything I can find from the original forms, and I'm going to factor it. So for the top I have x minus 3, x minus 1. On the bottom I have a GCF of x, and that leaves me with the difference of squares from there. So then I'm going to say x plus 3, x minus 3. So I know I've got a hole right here. Okay, so the things I can find from here, I can see that the top tells me that the x-intercept is 1, 0. I can see that there's a vertical asymptote at x equals 0, and there's a vertical asymptote at x equals negative 3. And then I can see there's a hole at positive 3. So positive 3. And then I'm going to find the y-coordinate by plugging in a positive 3 to all the factors that did not cancel. So 3 minus 1 over 3 times 3 plus 3. That gives me 2 on the top. And then on the bottom I have 3 times 6, which is 18. And that simplifies to 1/9. Alright, and then down for the domain, I can go ahead and say all real numbers, x cannot equal 0, x cannot equal negative 3, x cannot equal positive 3. Okay, so the rest of it I need to find using the graph itself. So what I'm going to do first is fill in the asymptotes that I know. So x equals 0 is an asymptote, so I'm going to go ahead and put a dotted line right there on 0, like that. And then I know that we have one at negative 3 also. And y equals 0 is an asymptote. And now I'm going to go ahead and graph it. So if you have an updated version of the calculator, you can hit alpha y equals, and then you'll be able to plug it in as a fraction. So x squared minus 4x plus 3 over x to the third minus 9x. So if you can type it that way, do it that way. If your calculator is not new, like you try to do that and it doesn't work, then what you can do is put parentheses around the top and the bottom, and it will give you the same graph. So x squared minus 4x plus 3 divided by x to the third minus 9x. Okay, so we're going to graph it. And my window is zoomed in, but we can actually kind of, I'll go ahead and change it. This way it matches up with what's on your paper. Okay, so here we just need to figure out what's happening to the left of this vertical asymptote in between these ones and to the right. And so what I'm going to do is I'm going to hit second trace, option number 1 for value, so I can just plug in some x values and then kind of draw a little sketch. So negative 3 is the asymptote, so I'm going to do negative 3.5 to see how close it gets to the asymptote. So at negative 3.5, it's at negative 2.5-ish. And then negative 4, -5, -6. And so you can see what's happening is it's getting closer and closer to that horizontal asymptote. Okay. And then I need to know what happens between -3 and 0. You can see it doesn't really look like a parabola shape. I mean, it's kind of U-shaped, but it's also kind of funky looking. And then I need to know what happens to the right. So I'm going to do 0.5. Hope you can see that. Let's do 0.25. Right there. 1. Oop, crosses the asymptote right there. 2, 3. 3 is the hole, don't forget that. Oh gosh. Okay, so if you can see what happened, I was just plugging numbers in there. So as I plug in, so right here we're going to come from the asymptote, the vertical asymptote. It goes over the horizontal asymptote, and it bumps up, and the bump up happens at 2, it kind of looks like. It bumps up to 0.1, at 3 you have the hole, and then at 4, oh, it's still going up. 5, 0.1, 6. At 6 it starts to go down again, so it bumps up a little bit, and then it comes down. And make sure you draw the hole, so I'm going to look for that when I grade these. Alright, so this graph is kind of complicated. Okay, so there we have our sketch. I made sure I drew the hole. I have all the asymptotes drawn. Now I need to look for a local max and a local min. So, I know that on this one, we have to look for mountaintops and valleys to kind of see the max and the min. So I'm going to look over here. I don't see any mountaintops or valleys, but right here I do see a valley right there, which means I've got a min. So I'm going to do second trace, minimum. And I'm looking over here, so I'm moving my cursor over there. Oop, went too far. And my minimum is -1, and you don't have to write this as a decimal. You can see like my calculator's trying to be accurate, it's just not doing a very good job of it. So writing -1 is fine for that. So next we're going to hit second trace, we're going to look for the maximum, and we know that after it crossed over the asymptote it bumped up, which is what it's going to do. If it crosses over an asymptote, let me draw a little sketch. You do not have to draw this on your notes. But if we zoomed in, we'd see it goes up and it would bump up and then it would kind of level off. That's what it looks like when you cross over an asymptote, and so that's what's happening here. So I'm going to hit maximum, and I know it's on this side of the graph, so look at your y values. So, okay, I've got a negative y value, so I'm at the left side of it, and then I'm watching it. It went over the x-axis. It's going up. It's still going up. Now it's going back down again, which means I'm on the other side of it. So I can press enter. And now what's happening here, it says it's at 3 and 0.111111, but not exactly at 3. What this is it's looking for the hole. The hole must have been the very top of the maximum. And so here we're going to say that there is no local max, and we're going to say because it was the hole. No, I will not do that to you very often. So mostly you'll be able to find it, but this one is kind of an interesting problem for that. Okay. Now to find increasing and decreasing intervals, I'm going to go ahead and label this on my picture. So I have decreasing right here. This is overall going down. this is decreasing until the point where we get to the minimum, and then it's increasing. And this is going to be increasing up to the point you get to the whole, because that was like a high point, and then it goes decreasing from there. So, for the increasing intervals, we have from the minimum up to the asymptote. So the asymptote was at 0, and the minimum was -1. So I'm going to say -1 to the asymptote of 0, and then from 0 up to the whole, and so 0 to 3. And then the decreasing intervals would be from -infinity to -3, where the asymptote was, and then from -3 to where the minimum was, and then from the whole to positive infinity. Okay. Alright, and then the range we're also going to get by looking at the graph. So I'm going to go ahead and write the domain with the other notation in case you're more comfortable with the interval notation of the set. So for domain, I'm going to say it was -infinity to -3, -3 to 0, 0 to 3, 3 to infinity. Okay, that's one way to write your answer. So I went from -infinity to infinity, but I skipped -3, I skipped 0, I skipped 3. For the range, if we look at the bottom of the graph, it starts with an arrow going down, and then we can see it's going, like we have all the stuff that goes up to 0. This goes up to 0, it goes through 0, and then it goes to the whole, which is a value of 1/9. So I know that I have -infinity all the way up to 1/9, and I cannot include 1/9. Right? And then these go back down again. And then it looks like, and especially if you look at your screen, it looks like there's a little gap happening in there. We have like a little gap right in here. So 1/9 is over here somewhere, and then there's this little gap. And so now we need to consider what that gap is. And if you look at your minimum, the y-coordinate there is a 1. So we have a gap from 1/9 to 1. So then we're going to say 1. And this part goes up forever, arrows up forever, so infinity. Like that, and actually you can include the 1 that's a real point on the graph, so that should be a bracket. Alright, so if you wanted to write these two answers, then that's fine. If you wanted to leave your domain like this, then your range should have been written as y is less than 1/9, or y is greater than or equal to 1. And so you don't have to write all those down. You would either write these two, or you would write those two. It's up to you. And then for now, leave the part we're not talking about limits yet, so once we do limits, we'll come back and we'll answer that part of the sheet.